Good morning or good afternoon, Matteo. How are you doing?
Hello, very well, very well. I am excited to be here speaking about Pino at NodeConf again, like a few years back. I think it was 2017 or 2018. I don't remember. It was quite a fun story. So it was with David Mark Clemens doing the talk.
Yeah. So you are also with us tomorrow doing a workshop, I understand.
Yes, on Fastify. So tomorrow we're going to cover the basics of Fastify, and you can get to learn the framework if you want to join. There are still spaces, so if you want to book it on Tito, you can totally. It's 20 euros. It will all go to charity. So why not?
Yeah, I understand you just opened up some more places for that this morning. So if people are quick, there are still some spaces there for them.
So yeah, it's there's still some spaces. Still some spaces open, so you can grab them if you would like.
And you are now chief software architect at NearForm. Can you tell me a little bit about what that means?
I don't know. You still have a job? No, I'm joking. Sorry. It's what it means is that I'm leading the hard technical problems. And I'm trying to help clients developing new architectures for their solution project, or to help them improve the performance, scalability, or just make it improve the developer experience of their toolchain. So if you can just grab me, and we can go through things together. I'm leading a team doing all of that, and on top of that, I'm also doing. In charge of the developer relations effort at NearForm. So you can even, see a little bit of our talks and stuff going around, hopefully more in the future. So.
Brilliant. As well as speaking at NodeConf remote, you also do a huge amount towards the organization. So a big thank you to everybody in the audience, and to all of the speakers, and to everybody to you for making a huge proportion of this event possible.
Thank you.
I don't often get a chance to properly thank Matteo for the work, so I wanted to do it now.
Yeah, it's very hard, I'm not taking it well. Amazing, Kate.
I'm going to hand out Matteo. And so here we have Matteo Collina with multi-threaded logging with Pino.
Hi, everybody. So I'm Matteo Collina. You probably have been introduced me by Katie. So, you've probably seen the introduction. Hopefully you will get a few things, a few bites from me. So first of all, take 1 minute to open Twitter and follow me at Matteo Collina. So I will probably mumble about Node.js and a bunch of other things, open source JavaScript on Twitter. So please take a minute to follow me. Anyway, we are going back to talk about multithreading. How can we do, why is multithreading so important? It's a new thing in Node. And why, we are doing multi-threaded logging. Why is that even a thing? And why it's important. So, but let's just go take one step back. So anyway, a little bit about me. If you don't know, I am part of the Node.js Technical Steering Committee, created two frameworks, Fastify and Pino, one we are talking about today. I'm probably a software architect and consultant. I started recently a newsletter, so another bit, you can find it on my Twitter profile also, but if you go to nodeland.dev and hit subscribe, you won't regret it. It's a weekly newsletter about some of the open source stuff that I do. So you can get a sneak peek on what it's about to come in Node.js, Fastify, and Pino. So, just to give you a hint, I am a 6 billion download person on NPM, so I don't know what that means, if you even, believe what I say or not, but that's what it is. Anyhow, so part of the reason of what I do is to balance between consultancy and the ecosystem. And this comes, and then this library and this talk and Pino comes from for keeping that balance. So back in 2016, we created Pino, which is the fastest logger for Node.js. And now it's downloaded roughly 8 million times per month with 4 collaborators. And we have just released version 7 last week. Hooray, everybody! We have version 7 of Pino out. I'm so happy about it. So how do you use Pino? You require Pino, or you can import it. It doesn't care. You can just use them with ESM as well. And you just create your logger, and then you start logging, and that's it. It also supports these nice features called child logger, so you can specify properties and build through it. Note that this Pino generates new line delimited JSON. So it's a JSON followed by a new line. So you can parse one line at a time, and that's your log delimiter. All of these is covered in NodeConf 2016. So in the talk, the cost of logging that I did with my friend David Mark Clements. You should watch that talk. It's probably one of the best talk that me and David have done. To be clear, the talk started. To be clear, I don't think it got into the recording, but Emily Rose, who was emceeing NodeConf those days, actually wrote a poem for us before we went on stage. Anyway, let's read a poem that she wrote for us. Whatever. It was completely mind-blowing. Anyhow, the gist of it is that Pino is really fast, and you can actually, and logging, it's actually a significant bottleneck for most applications. So the more you log, the more your applications slow down. And you can see this happening with most of the loggers, and to some extent even with Pino if you log a lot, but it's still the fastest of the alternatives. So, do some benchmarks and see. So how come Pino is fast? Well, this is actually very important. This is why I wanted to cover this. So let's go through the event loop. You've probably seen this slide a few times, but I'm going through them again. So whenever you receive an event, an IO event, you receive a new request, a new socket gets open, you receive a new request, new HTTP request, something like that. The event loop will call some C++, then will call some JavaScript that typically goes around and allocates some promises, typically, and which then are executed by the task queue. And after all the dust is settled, the event loop continue until the next event, right? Note that the event loop is blocked in between, okay? This area that you can see here in between is actually where the event loop is blocked. So what actually means that if, what actually means is that if we want to increase the performance of our code, and we want to keep the event loop spinning and receiving a lot of events, we need to minimize the time it takes to execute this JavaScript function and this C++ block, as well as the number of promises that we are allocating. So, it's what happens if one task is slow, okay? If we have a slow IO operation, like writing something to standard out. Your application increases the amount of concurrent tasks. So I start sending something to standard output or to a file or to a network socket, and this increases the amount of concurrent tasks. However, the more concurrent tasks that I have, the more memory consumption I have. Why? Well, because I'm creating things to up and back. I will be waiting for new events in the future, right? So that's why I'm keeping more memory, more objects alive. And if I increase the memory, then it also increases the time it will take for the garbage collector to clean it up. So I'm making more, it actually requires more CPU. So what this means is that then the CPU, the garbage collector, will start stealing CPU cycle from our JavaScript critical path, slowing everything down. So this, to me, this essentially is what I wanted to convey here is that latency and throughput are connected in Node.js applications. So If you want to increase the throughput, you need to lower latency and vice versa, okay? Why does it matter? Well, it does, because if we want to log a lot, if we're sending a lot of logs and we want to ship them, for example, to Elasticsearch or through some other destination that is remote, well, we don't want to be waiting a long time on those I/O operations, okay? And otherwise, we will be filling memories with logs, which I've seen happening, okay? I've totally seen it happen. We have seen application crash out of memory because of too many logs. So going back through here, what we want to minimize is this bit, but also only have as many as those I/O steps as we want them to be. So one of the important bit of Pino is Pino does all the processing in a synchronous manner, in one tick of the event loop. So all whatever Pino allocates, it's done in that single step. Okay, there's nothing lingering afterwards. This makes it incredibly, this is reduce a lot the memory consumption and makes it incredibly fast. So we ended the talk of in 2016 with this sentence: Pino is more than a module, it's a way of life. In fact, Pino comes with a lot of tooling around it. Some of those are what we call them transports. So, you know, if you want to send the logs to Elasticsearch or do log formatting like pretty printing so that human being could actually read it well, we recommend it to use a separate process. So we don't want to be doing any I/O. So instead of doing any I/O, we would have just done our bits. So this is one of the most important parts. However, people, you know, when we push this idea, this is great for typically Docker containers, but a lot of users kept asking for those features in. And it was like, you know, why should we have more, how can we pack this feature in without destroying performance? Not that doing those type of things in process inside the main thread was one of the major problems of most of our other loggers. So this was actually a design choice. However, so using a separate process is actually hard for most teams. So how can we do it? Like, what could we do it? Well, our solution was to use worker threads. Worker threads are great, and you can actually spin them up pretty easily, and use post message to send things back and forth. They also have a thing called atomics, and remember them. Also, Anna mentioned those in their talk. Those are great. Okay, atomics are fantastic, and you will see why. Now, could you use worker threads to build transport for Pino? And yes, we could. In fact, at the beginning, this idea was done by Mark Martin, and again, 2016, 2017, those times, in this library called LogPP, which actually use a native add-on to actually achieve this. So turns out that this was not really doable as it is because post message is slow. Well, it's not slow, but it's still not fast. And it's, typically a round trip back and forth, it takes around 8 milliseconds, which is on my machine, which is not fast enough because our maximum latency here is too high for the latency that we want to achieve. Because this will make that we can do maybe 125 messages per second, which is likely not enough throughput that we want to achieve. Also, these would if we do this, we cannot really block. Like all of these are synchronous, so it won't be doable for our goal of keeping everything synchronous in a single tick. So I created a new library, okay? At the beginning, a good chunk of this work was done by my friend, David Mark Clements. However, it got stuck. It was Christmas last year. The Christmas holidays last year took like 10 days to actually prototype this out. It got stuck. So he asked me, Matteo, can you please take this and rejiggle it a little bit? and make sure that he fixed certain bugs. So I ended up re-implementing everything from scratch because I couldn't really spot immediately what was the problem in Dave's code. So at the end, we came out with this library called ThreadStream. ThreadStream is, it offers a stream-like API. It's not actually a node stream or a web stream. It's a node stream-like API with some added methods. More importantly, it has a .write, which is what we want. And these uses a ring buffer to achieve high throughput. This is actually pretty good. Just using this will, make your code, instead of just using fs create by stream, passing through this, will probably make your application 2x faster. Why? We'll cover it in a second, okay? So, but more importantly, all the writes in these are synchronous. How? Okay, so we have the main thread and our transport, and we can say we want to send some logs from one to the other. What we use, as I said, we will use a ring buffer. So we have two memory areas, a read and write memory areas, which are just pointer into the main ring buffer. So what we do is so the thread stream locks on those two memo data area, the read and write, and stores integers in there using atomics. Those are actually pointers to the ring buffer space. How is the write being done? Well, what the main thread does, it takes a chunk of memory and copy the log message within the ring buffer. This is implemented as a shared array buffer. So, and after that's done, it moves the write pointer to the end of it, which is great, okay? Because then the transport could actually use atomically check the write header and the write pointer, and go back in and move it up. So and read from where it was left to that point. So all of this works. It's proven, and it's super fast because moving the logs, the data object from my stream, from the main thread to the transport is just a memory copy of a JSON string, which turns out that we can use this technique to implement transports. So how do we implement transports? Well, you can just pass the transport option to Pino, and you can use a few transports. So for example, we have Pino file to write to a file. It's you can use Pino Elasticsearch to send things to Elasticsearch if you want, or you can write even your own here, or you can use, for example, Pino Pretty to make it nicer to read. So it's pretty cool. So how do we implement a transport? Well, we can just use this library called Pino Abstract Stream. Pino Abstract Stream is just an utility that will make everything set up. You can do it manually, but it's probably not super straightforward, so you might want to use that. You can use both async iterators or streams. It's great. It works wonders. There is actually, I wrote even a simple utility called HWP to do this in a more nicer way. So you might want to check that out. It's all in the documentation. Now, we couldn't implement something that was just like Unix-like and without the concept of pipelines. So we can actually implement a pipeline which enables the concatenation of multiple transports, and it's great. And we can actually do that. It's phenomenal. And you can connect multiple transports together. Well, but we have a problem, the exit problem. Now, you have your app, okay? And when you hit Control-C, at some point, the application will start to do process.exit. Now, the problem here is that the writing and the delivery happens in another thread. So how can we make sure all the logs are flushed? Well, here you can't. Here you have an exit. So node core emits an exit event, and at that point the event loop is dead, is done. So you can't execute anything. Note that after that happens, even if you use console log in the worker thread, will not work. Why? Because console log does send data back to the main thread for printing. So no, even that does not work. So no asynchronous code is allowed at that point. How did they fix it? Well, you can use using the transport, the remote, the separate transport is great, because when exit it happens, we can trigger a flash sync and send a flashing sync command to the transport and synchronously block using atomics up until the transport is done. Now the transport is still the event loop is still running for transport. So we can actually do this. So we can actually perform all the synchronous operations that we want inside the transport, and then unblock the main thread after that is done. It's great. How is this implemented? Well, this is a simplified, or copy and pasted. I left out some code. So how does this work? Well, first of all, we get the read buffer, as I said, using atomics, and then and then we tell that we have finished writing, which is a -1 in our write buffer. And then we send a notify to tell the server, the transport, if it was blocked. And then after it, we do we spin every second, waiting for that to have finished. Now, the reason why we do this spinning, it's because we don't want to deadlock forever. So probably this will become configured in a latest version. But it works well enough in my tests. I also create another library called onExitLeakFree. onExitLeakFree is really nice because it allows you to do to set up the event handlers for the on process without leaking memory. So it's great. I just want to conclude that that we have also done some benchmarks, and we have measured and verified that using this new transport system is equal or slightly faster than what will you usually use in applications. Note that by default Pino logs synchronously, at least in version 7. This probably will change in version 8. But if Pino logs synchronously, if you are sending data using even a separate process, you will get very bad performance. So you need to use asynchronous logging, and with two processes. So the result is that using a transport is a little bit faster. Using a worker thread is slightly faster than using a process. So we got some good news out of it as well. I just want to thank you for your time. It's you can reach out to me on Twitter and via email. Before we leave, before we part, I have a slight little demo for you. So our transport works, okay? So we have Pino, and then we can create our transport. We can also pass the transport option to the Pino constructor, and we do some logging, okay? Now, let's run this. And you see, this has been running correctly as we would expect. And it's you see it's get to standard output with Pino Pretty. We are writing to a file, an out file, and then we are writing to Elasticsearch. So let's see if I get out. And we have our data. Okay, this is an error level. Okay, this we have our logs. Okay, which is great, right? Oh, sorry. And so we have this. Okay, so we have only the warn and error. Now let's see if it happened to run into Elasticsearch. So I can refresh this, and you can see we have some logs. It's 14. Now you probably don't see this perfectly on the stream, so I'm not going to spend so much time on this. But it's all working correctly, and it's all really, really fast. So again, thank you for having me, and I hope you like this talk. And thanks.
Thank you, Matteo, and thank you for that little demo at the end. That was really, really exciting. It's totally worth following Matteo on Twitter. He puts up some great tips and techniques and some ideas up there. And your new newsletter is really interesting and exciting as well. So I do have some questions for you.
Hooray!
So, Francis asks, are transports processing JSON logs as objects or as sterilized strings?
So it's we use serialized strings to move things between the main thread and the transport. So it's strings, essentially. They will be reparsed on the other side.
Okay. Every piece of information out there about worker threads is about avoiding blocking the event loop with expensive CPU-bound tasks. However, this doesn't seem the case here, as the log messages are tiny. Why is this still so fast?
So, as I said in the talks, it's you can use atomics to do a huge amount of things, and they are really, really flexible. So even if something it's not super file, even if the log processing of one single message is not expensive, you have a lot of them. So by writing them on a chunk on the buffer, we are enabling the transport to pick them up at its own pace, which means that it can actually take them at a larger batch than what the producer would do. So, and this is what makes it incredibly fast. And once you have a batch, that becomes worthwhile in terms of resources and CPU usage. So, hopefully that was clear. Maybe.
Okay, so here's another one. I'm using Winston. Should I switch to using Pino?
If it works for you, no. That's my usual recommendation with any of my libraries. Okay, if something works for you, you shouldn't change it. Don't believe me. Okay. However, if you have a problem, you might really want to switch. I have seen a few clients of ours bump to arrive at 300, 400, 500, 600 megabytes of RAM just because of their of Winston. Mainly because it was using some remote transport to do some, log manipulation, and all of that was actually being taking a lot of effort.
Okay, yeah, it does make sense though. If it's not broke, you don't need to fix it. So,
yes.
Jonathan asks, do you have some feedback about Nest.js Pino? Is it based on Pino and it's using the async hook? Oh, sorry. Is it based on Pino and it's using the async hooks?
I don't Nest.js Pino. It's probably based on Pino. However, I have nothing to do with it.
Okay.
I don't know.
That is absolutely fair enough. So tomorrow you have the workshop. Do you want to do just another plug for that?
Yes. So tomorrow, if you're interested in Fastify and Pino as well, but probably more Fastify, we have a Fastify workshop. So if you want to know how to build REST APIs or maybe GraphQL APIs, maybe, I don't know, on using Fastify, you can join us at I don't remember the time in UTC. So we have, let me check it out very briefly. You can join us at 4 p.m. UTC for the Fastify workshop. I know there are still slots open, so feel free to join. Also, there are slots open for most of the other workshops, so you should join all workshops if you want to learn something new.
Thank you ever so much, Matteo. I haven't got a poem for you, but I have been knitting this here scarf that I'll get to you next time I see you. So
I can't wait. We will meet each other in November, so
I'm looking forward to seeing you in 3 dimensions then. So thanks very much. I'm going to wave you off into the abyss. It's lovely to
Yay,
see you.